Hello, this is part two for those who missed physics today. It's Monday 11/30/15, and we're back here after a vacation. So we hit the ground running by jumping back into our friction problems. And just as the video ran out, it wasn't really worth taping again there in the classroom. I just decided to tag on this few seconds that were missed. And so sometimes in our equation, often the equation looks like this: the force of the pull of the car, whatever we're talking about, minus the force of friction equals, that's the sum of the forces, the net forces, equals MA. So a lot of times we have that, and the force of the pull is this, and force of friction ends up being MK or MS, depending whether mu sub K if it's moving, mu sub S if it's still. Force normal, which I'm going to write as mg, because that's what force normal is on a flat surface, equals ma. So, as I already set that up for you earlier today, this is the equation that will help us through our problems, most of them. And when we have that situation, sometimes we have to find acceleration in other places. So some tools from the past that will help us with acceleration, with sometimes we can say, I think I had this on the very end of the video, acceleration is change in velocity over change in time, which is velocity final minus velocity initial over time, which we've used that in the past, and also the squalor. We can sometimes get acceleration from that equation or any of the other equations too. But these two I think will pop up in our work today. Then another tip before we go back into that worksheet is that a Newton is a kilogram meter per second squared. So sometimes our problems will throw in hours or kilometers, so we'd have to switch those quantities so that we may use newtons in our answer. So keep an eye on the units. All right, that was the end of our instruction for that day today, and we started this worksheet again. So I couldn't remember if you had it or not. So we had started this on Friday before we pulled out our pumpkin cheesecake. Remember, number 3 was missing. So if you don't have that with you, you can just stop the video and use this and just work it on your own paper. And there are 10 problems. So we worked on that, and you should have been at least through number 7 by the end of today. So I think some of you have this on Friday, and some of you weren't with me on Friday, so I don't think you have these done. So if you would work from 1 to 7, and we're going to go on and finish 8, 9, and 10 in class tomorrow. And there's some answers down here. All right, I think this one I got a little differently. I got 0.12 without the 3. All right, so that's it for physics class, and I hope that this is helpful, and go ahead and work these problems using that basic equation that you saw in class today and which I just showed you on here. All right, talk to you tomorrow. Ciao.